Okay, so we've got a question here from the topic of electromagnetism. The question is, what is the definition of a magnetic field? The second part is, how does this compare to gravitational field and electric field? So we're going to use relatively simple definitions for this. We are going to say that a magnetic field, a mag field, is a field which exerts a force on moving charged objects. Now we should note that the charged objects, the force exerted on the charged objects is not in the direction of the object's movement. It is perpendicular to the object's movement. So the force is perpendicular to the movement in this case. How does this compare to a gravitational field? Well, a simple definition for a gravitational field is a field generated by mass which attracts masses. Essentially, mass attracts other mass. This creates gravitational fields. You could say energy as well, but for the purpose of simplicity, we'll just say generated by mass. And then an electric field is a field, F-I-E-L-D, which is typically generated by charges of some variety, and it exerts a force on moving or stationary charged objects. Exerts a force on moving or stationary charged objects. Now, when we compare the three of these, the magnetic field is distinct from the gravitational field and the electric field, or magnetic fields more broadly are distinct from gravitational and electric fields, in the sense that the force in the case of the magnetic field is perpendicular to the movement, right? A particular movement is required through the field. The force ends up perpendicular to that field. That is not the case for gravitational fields. It's not the case for electric fields. Electric fields accelerate particles in the vector directions of those fields. Gravitational fields tend to accelerate particles in the direction of those fields as well. So this is how they compare, and these are simple definitions for the three.